Before we begin today's notes, I'm sitting here with my daughter McKenna, and she'd like to tell you a story.
Good morning.
Do you want to tell them a story? Tell them about your day yesterday.
I was eating waffles.
You ate waffles? Anything else?
I have one. This is Spencer Bunny. It's a tiny blue bunny. And this is Broken Bunny. She's a blue bunny. And this is McKenna Bunny. She's a purple bunny.
Oh, thanks, McKenna. She just showed you all of her stuffed animals, so I hope you like seeing them. Maybe I'll post a picture of them so they know what you're talking about, okay? So for today's notes, I would like for you guys to actually look at this review and do a couple things with it. For part A of each of these, I want you to think about the circle of life. So if I said 2 to some power is 16, you would tell me that that value is 4. So think about it, do whatever it takes. If you even have to write down 2 to the x power equals 16 and get it that way, rewriting 16 with a base of 2, do what you have to do for part A to get that answer by thinking about it. For part B, I want you to use your calculator. So you're going to go to your, snap. Say, snap, McKenna.
Sat.
Close enough. So you're going to go to your calculator and you're going to hit the log button and you're going to do log 16, hit enter, and then you're going to divide that by, hit the log button again, 2, hit enter, and then write the answer you get there. So if you could please complete parts for 2, A and B, and 3, A and B, pause the video and then come back when you're finished. At this point, you should have finished all of the questions in the review. Hopefully you noticed that the answers to both part A and part B were the same for each number. In other words, you're seeing a formula that I am going to be teaching you today called the change of base formula. I need to get out of this room. It's getting loud. Hey, Spencer, say hi to all my students.
Hi, students.
All right, so if you could please copy down this formula. It's called the change of base formula. And what you'll notice is that if you have a log with some base B and the argument A, it is equivalent to finding the log of the argument over the log of the base. So in other words, if you look at part A for number 1, notice that I rewrote it as the log of the argument. That's what was on the top of this log right here, over the log of the base. So this was the argument, and the other number in the denominator is the base number. And notice that gives us the equivalent form, and it gives us the same answer. So that is an actual property that we're going to be using today. So let's look at the first 4 examples to see what we're going to be doing. It says use the change of base formula and your calculator to evaluate each log. So what we're going to do is we are going to rewrite number 4 as the log of the argument, which in this case is 1 over 128, divided by the log of the base. Now, I put the parentheses there just because in your calculator it's important to always close those parentheses. So if you're doing number 4, you could say log of 1 divided by 128, and as long as you close those parentheses, you can then right away divide by the log 2, and we're getting this answer of -7. This is the same thing as saying 2 to what power equals 1 over 128, and that's what you're finding, but now using your calculator to do so. On number 5, you may say, well, then why don't I just do this in my head? 7 to 1 power equals 84. The problem is 7 to some power equaling 84 is not a nice number. So what you can do is you can rewrite this as log 84 divided by log 7. And then I will use my calculator, log 84 divided by log 7. And you're going to get approximately 2.27. What did it say to round to? Round to the nearest thousandth. So 10th, 100th, 1000th. So this would be a 7. Moving on to the next problem, same thing. Just knowing this change of base formula is very helpful. You're getting the log of 150 divided by the log 6, so the argument over the base. So in our calculator, we could do log 150 divided by log 6, and you're getting approximately 2.796. So again, if you're thinking about what this answer means, this means that if I take 6 and raise it to this power I just got, it's going to equal 150. Now, obviously, it'll be a little off if we round, but it'll get you very close to 150. And then the same thing for this last problem. So with this, I know 11 to some power equaling 1, it has to be 0. But just to confirm it in our calculator, we get log 1 divided by log 11. And you will get that answer of 0. Now, honestly, I don't know if the other teachers are teaching this trick, but I don't feel right in not showing this to you guys. So I just want to show you guys how you can actually do this in your calculator. Some of you have this, some of you do not. If you don't, you would have to update your calculator to get it, which involves cables and things like that. So I apologize if I can't do that for you. But if you have it, if you go to math and you scroll down, there's a button that some of you will have that says log base. If you hit it, it allows you to fill in a base number and then put in the argument value. So I want to show you guys this because I think it's right that you know how to use this on your calculator. At some point, you may take the SAT, ACT, and I want you to know that that's there to help yourself out. So feel free to use that as well. It is important to know the change of base formula. So make sure you do understand that, but at the same time, I just want you guys to see that that's there. Okay, so let's do some solving. We're going to be using this property when we solve. So let's talk about solving exponential equations and do a quick review first, and then we'll get to, uh-oh, my screen froze. No surprise, a lot of things open. It always worries me when my screen freezes and I have to like show you my other screens because I do a lot of weird things on my iPad. And if you notice, I had an email open, Target orders coming today because I'm not going to the stores. Let's go to the right note sheet. Here we go. Okay, so sorry, we're back. If you look at the first example here, I hope you remember this from last week when we had to, actually maybe it wasn't last week, maybe it was the week before, it was before spring break, I believe, when we were solving exponential equations and you had to get the same base on each side. Remember that if we want to solve for x here, we need to get the same base. So right now, I'm going to rewrite the right-hand side with a base of 2. If I rewrite 32 as 2 to the 5th power, I can then distribute this exponent because we have the power to a power property. And then you can set these exponents equal to each other. So we get that 4x equals 5x minus 5. And then I can bring the x's to one side. And then I can divide by -1 to get x equals 5. So that's review. Hopefully you remember that. Same thing with part B. If you want to get a solution for x, we need the same base. So I can leave the left-hand side alone, but I'm going to rewrite that 81 as 9 squared. And then I can distribute and get that 9 to the 2x equaling 9 to the 6x minus 4. And then I can set those exponents equal to each other once I have the same base. Now, some of you might not have used a base of 9. If you kind of worked ahead on this, you might use a base of 3, which would also work. And then dividing by -4, we get x equals 1. Now, you may be saying, Schmear Bear, what does this have to do with what we just did up above? And there actually is a huge connection because the next set of problems we're going to look at, I would encourage you to first think about if you can get the same base on each side. But there's a dilemma here. I can't rewrite 15 with a base of 4. So the reason I wanted to show you these problems first is that sometimes you can get the same base on each side. And if so, it makes the problem so much easier to solve. But if you cannot get the same base on each side, you are going to rewrite in log form. Now, what do I mean by that? If you guys remember the first day of notes, intro to logs, if you need to go back to that note sheet, you pause the video, go back. The intro to logs note sheet showed you how to rewrite something from log form to exponential or exponential to log. If you guys remember, this number we call the base, and that becomes the base of your log. Remember that the exponent goes on the other side of the equals, and then the 15 becomes the argument of the log. If I were to do the circle of life, do you guys see how it would give me 4 to the x equals 15? And that's the same exact thing it says for part A. Well, why would we rewrite in log form, right? We don't like logs. Like sometimes when you look at logs, they look scary, they look complicated. But when we rewrite in log form, this allows us to solve for x. So right now, you can get out your calculator and you can do one of two things. If you have that log base button on your calculator, you can go to math and you can scroll down, log base, and you can type in a 4, and then for the argument, you can type in a 15, and you can get the solution for x to be approximately 1.953. If you don't have that button, no worries. All you have to do is use that change of base formula, log 15 over log 4, and you can type that in and get the same answer as those that do have that option to change the base. Okay. Personally, I know that a lot of people were like, oh, change a base. Like, let's just use the button on the calculator that says change a base. Sometimes I think it's faster just to type in log 15 divided by log 4. And in fact, if we were in school right now, I would race one of you guys and show you that I can get the answer just as fast, not using that than I could, or than maybe you could using it. So I know, game on, right? Challenge. I know you want to challenge me now. So let's look at the next question. Maybe we can do a race virtually. First, let's get it set up. If I said to rewrite this in log form, okay, so remember, we can't get a base of 5 on the right-hand side. So I'm going to rewrite it, and I'm going to put the base of the log as a number 5. And then remember, on the other side of the equals goes the x plus 2. And then the argument is 22. So if you want to find this right-hand side, we can race if you want. Some of you can use that math option, and then others of you who don't have that math option are going to be doing log 22 over log 5. All right, you want to race? So for those of you doing option 1, and then those of you, I'm going to do option 2. On your mark, get set, go. There we go. Who got it faster? Who won? We get 0.938. And then that is equal to x plus 2. So it's an approximation because we had to round. And then this problem has an added challenge because I want to solve for x. That's not my solution for x. That's my solution for x plus 2. So as a final step, I have to subtract the 2. So I'm getting negative 1.062 equals x. Oh, is that it for the notes? Oh, and then it freezes, so I have to like wait to see. Here's my children. Oh, closed the wrong thing. Oh my gosh. I am a hot mess, actual hot mess right now. Oh, and then I went to the wrong note sheet again. All right, so here we go. Oh, there's one more. Okay, so one more. I know the anticipation is building. You probably have finished this note sheet by the time I'm getting to this part C, just because I'm taking forever. So this final one, unfortunately with this, we have to isolate this part here that has the x. So as always, we've seen problems like this in different types of examples. We have to get rid of that negative 2 first to isolate. So we're going to get this 6 to the 2x equals 20. Now, because I can't get a base of 6, always check for that because, again, it takes the problem, makes it so much easier. But if you can't, we're going to rewrite this as log base 6 because, remember, this is your base. The exponent goes on the other side, and then the argument of the log is that 20. And just do a quick circle of life, make sure you get the same thing. And then we can use our calculator to find this value on the right. So again, if you want to use that, we can do another race if you want. Maybe you didn't beat me the first time, but you want to try to beat me the second time. Let me just get it set up. So you can do either way. So on your mark, get set, go. Log 20. I'm slowing down. I'm slowing down. You get 1.672. And then note on this one, we're not adding or subtracting to get x. We have to divide that answer. So we get 0.836 equals x. So that concludes the notes that I'll be doing with you. At this point, my screen froze, which is appropriate because at this time I would like for you to pause your screen and complete the U-Try. And then when you're done, restart the video and you can check your answers with mine. Probably didn't even have to freeze your screen. You probably could have just waited for me to, unfreeze mine. So the answers for the U-Try, for that first one, you can rewrite that in log form. Make sure you did that correctly. And then from there, you can either use that log base on your calculator or use the change of base formula to get that answer. Same thing with part B. With part B, you should have rewritten in log form. Just don't forget that once you get that answer, you had to add 1 to it. And with part C, don't forget to divide by the 5 first. Rewrite that in log form. Either use your calculator or the change of base formula to get that 1.661. Divide that answer by 3. And then wham bam, thank you ma'am.